Today we will discuss the coordination property of the coordination compounds. Coordination compounds, the property of the coordination compounds will depends upon the metal, oxidation state of the metal, and that depends upon the strength of the ligands. On the basis of the magnetic property of the coordination compounds vary depending upon the different type of the behavior of the coordination compound. First of all, on the basis of magnetic property, the coordination compounds are classified as diamagnetic, paramagnetic, ferromagnetic, ferrimagnetic, and antiferromagnetic compound. Diamagnetic compounds are those compounds which are slightly repelled and the magnetic property of which decrease linearly with the strength of the external field. Paramagnetic compounds are those compounds which are attracted toward the magnetic field and the magnetism is linearly with the increase in the strength of the external magnetic field at constant temperature. There are two types of the paramagnetism: strong magnetism and weak paramagnetism. The strong paramagnetisms in which the magnetism is observed as temperature dependent, and in weak magnetism is observed for the non-metallic compounds, origin of magnetism compounds, in which there are the two type of the behavior of the electrons around the metals in coordination compound. That is the orbital moment as well as the spin orbital moment. But in case when the ligand, in case of the metal, in case of the coordination compounds, the ligand, due to the presence of the ligands, the metal electron cannot show the orbital motions, but so there is only spin moment is observed in coordination compound. But there are some exceptional case where there is orbital motion is also observed. There is a higher value of the magnetic moment that may be due to the orbital motion or may be due to the temperature independent paramagnetism. That is diamagnetism and paramagnetism. Diamagnetic compound induced magnetism moment is around given as 10 to the power minus 2 to 10 to the power 6 moles. There is no temperature dependence for the diamagnetic compounds. In case that is, there is a linear graph with respect to the paramagnetic as well temperature. In case of the paramagnetic compounds, the magnetic susceptibility increase with the decrease of the temperature, and it depends upon the temperature. To explain the paramagnetism behavior, there is a law, Curie law, that explains the magnetic susceptibility. Xi m is equal to C by 2, where C is a Curie constant. When we measure the magnetic moment of the paramagnetic substance, it will show that when we decrease the temperature, there is an increase in the magnetic susceptibility. And in this case of paramagnetism, there is only mainly the spin as well as the orbital magnetic moment, but that is given by the equations spin and orbital 2s plus 1 and n is equal to n plus 1 under root. That is spin only magnetic moment is observed for the coordination compound. Ferromagnetic compound. Ferromagnetic those are the coordination compounds which contains large number of the unpaired electrons, and due to presence of unpaired electrons, that they show higher magnetic behavior. in case of the paramagnetic behavior, when we apply the electric field, there is a change in the alignment of the electron species in a particular directions. As we show from graphical representation, when we decrease the temperature up to a particular Curie temperature, they show paramagnetic behavior with respect to when we decrease the temperature towards lower value, there is a sharp increase in the magnetic behavior. And to explain the behavior of the ferromagnetic compounds, there is also a relation x by is equal to c t minus theta, where theta is the Wish constant. At Tc, the thermal overcome the alignment and the paramagnetic behavior at absolute zero alignment is complete, and spontaneous magnetization has its largest possible value. Ferrimagnetic. In case of ferrimagnetic species, is the external field having magnetic domain where some moments are symmetrically aligned to oppose, but there is a net resultant magnetic field in the presence of the external field. Antiferromagnetism. In case of antiferromagnetic, it is proposed by the Neil. Proposed this concept in 1930. Interacting magnetic dipole on the neighboring atoms tend to assume an antiparallel arrangement, and net magnetic moment is zero. Antiferromagnetism occurs below the Neil temperature, and that is Neil temperature, that is Tn. Above Neil temperature, there is a normal paramagnetism. From the graph, it can also observe that antiferromagnetism occurs below the Neil temperature, and above the Neil temperature, there is a sharp decrease in the normal paramagnetic behavior. From this graph, we can see that a different type of the behavior is observed. In case of the paramagnetism, there is a sharp increase, and in case of ferromagnetism, there is sharp increase, and green color show that when there is a Q temperature, that is Q temp point is observed, there is a sharp increase in the magnetic behavior. In case of antiferromagnetism compound, up to red line, that is there is increase in the up to the Neil temperature, there is increase in the magnetism, but when we decrease the temperature, when we decrease the temperature, there is a sharp decrease in the paramagnetic behavior of the coordination compound. To calculate the magnetic moment, the formula for the spin magnetic moment is 2s plus 1 is under root, and the spin magnetic moment of coordination compound can be calculated by using this formula n plus 2 under root. N is the number of unpaired number of electrons. And to calculate the magnetic behavior of the coordination compound, there are two methods to calculate the magnetism: Gauss method and Faraday method. In course of Gauss method, sample suspended is in homogeneous magnetic field. Sample weight in and out of the field. Weight difference related to the Chi and field strength B. That is, by using Gauss method is very simple method, but in this case of Gauss method, we have to take the large amount of the sample. Second thing is that when when there is a small oxidation will occur, so we cannot calculate the exact value of the magnetic behavior. In case of the Faraday method, the magnetic moment is measured with the torsional strain. There is a small size. There the concentration, the sample size is small. And the benefit of the Faraday method is that it is highly accurate as compared to Faraday method. So in this chapter, in this lecture, we understand the magnetic behavior of the coordination compounds, and how it is measured and how it is calculated. Thanks.